Guys and girls, it's Know It time!
Alright, today I'm going to teach you the next part of transformations, and this is on stretches and compression. And if there's time, I'm going to teach you reflections also. Stretches and compressions. Again, you have to know the difference between theory versus a regular y equals to f of x question. A lot of people can't do that. So guys and gals, it's Know It time. Your favorite time of the day. Our traditional drawing. Compressions, yep.
Sir.
Voila, our traditional drawing. Okay. Here is where I'm going to start. Last time I did y equals to x. Then I've taught you how to do y equals to x minus 2. Today I'm going to change up slightly. I'm going to go y equals to 2x. See, I'm going to just circle a few things. This minus 2, that's called down 2, because we learned that already. This 2x, the best way to do this is just do a little table of values. So let's draw our table of values. X and y. Yep. X and y. So all we're going to do is just choose any number for x you want. Starting from 1, 2, 3, 4, and so on, so on. Okay. Guys and gals, take a minute and fill in your y value. This is going to be 2, 4, 6, 8. Who do you appreciate? There's only one answer for that. Not after that quiz, as Grumpy would say. I'm so mean sometimes. X, Y. If I were to write down the original X, Y, 1, 2, 3, 4, and this would be 1, 2, 3, 4. I want you to compare the different Y values. Here is my regular equation. Here is my new equation. So this 2, a lot of you say, hey, Mr. Snow, this 2, it doubles the y coordinates, which is true. So this is called doubles y coordinates. Just basic stuff, because it doubles the y coordinate. And notice the 2 is in front of x. Not anywhere else but in front. In this case, we call this is star. This is my vertical stretch by 2. It's a vertical stretch by 2. Okay, I just stretch it. To show you what a vertical stretch looks like, let's draw a little picture. And do it. Can you pull it down a little bit? Hi. Okay, so let's draw a little picture. Doesn't matter what it is. Let's draw a little circle. This is y equals to f of x. I want you to draw a new one on the exact same grid. What would y equals to 2 f of x look like? So you're going to imagine, you're going to take all these coordinates and you're going to change it by 2, multiply by 2. So what do you think the circle is going to look like? Bigger. So you're going to stretch it. So it's going to look like a little oval. Okay. Notice my x coordinate hasn't changed. It only changes the y coordinate. It could be something like that. I'm just guessing. That's what a vertical stretch. Because you're gonna stretch it. Imagine you have a hand here and a hand here. We're gonna pull. Okay, and that's what you get. This is called vertical stretch. Same question.
If it wasn't 2y and
2y.
What is that stretching vertically then?
I'm gonna show you in a second. So write the little things down. Star. Vertical stretch only affects the y coordinate. Okay? I haven't even touched the x coordinate yet. It only affects the y coordinates. And key, this is where students are going to make errors. Another star. You're going to multiply this time. We're not adding anymore. We're multiplying all of our y coordinates now. Adding was simply moving up, down, left, right. Now when you work with stretches and compression, you're going to multiply this. This is called vertical. What if I give you something like this? Y equals to 1/3 f x. We're going to highlight. See, look, y is by itself. 1/3 is a small number. So we're going to say this is a vertical. I'm going to call this V compression.
That's another question.
Question.
It can only shrink when it's less than 1 rate.
Yep. By, no, it has to be between 0 and 1.
Okay.
By 1/3. And I'm using compression because I'm shrinking it. A point 5, 9 lies on f of x. Find the new point. Using that, yep. So think about how you're going to do this now. You're going to compress this. So 5 and 9 doesn't exist anymore. Monica, take a guess. What is it? 5 and? You can't read it?
What's 1/3 of 9?
1/3 of 9, or 1/3 times 9 is 3. Yeah. So my new point simply is 3. Notice I'm not adding, I'm not subtracting, I'm multiplying. So your point, and another key thing, look, my x-coordinate hasn't changed. Because I'm only working with the vertical stuff. This is called vertical compression and vertical expansion or stretch. Next one. What if I give you something like this now? Y equals to f. But notice I'm going to do something different. The 2 is after the f in front of the x. Now this, we're going to highlight a few things down. Sorry? This is something called horizontal. And remember, everything that's horizontal is total reverse. You got to think it like that. Plus is actually to the left. This is going to be horizontal. Vanna, take a guess. What is?
It's not reverse if it's vertical.
Sorry?
It's not reverse if it's
Vertical is not reverse. So horizontal, it's in the brackets right now. So what is this going to be? Stretch or compression? Compression. We're going to write that as a compression. Vertical compression. Because it's inside the bracket. Because when you work with horizontal, everything is reversed. 2 thinks that, hey, Mr. that's actually a stretch.
So it's
But
like phase shift, right?
it's not a phase shift.
No, I said it works like phase shift.
It works like phase shift. Now, here's another thing that's tricky. By, we can't say it really by 2. You have to say by the reciprocal of that number. By, I'm going to write this out in bracket. By 1/2. We're going to write this down. Star. Use the reciprocal. Reciprocal. The reciprocal of 2 is actually 1/2. So if I have a point 4, 8. Okay. Harpreet, what's my new point going to be? 2, 8. What if I decide to be tricky and use A and B? Oh, now we can't do this, Mr. No. It's so hard.
Is it 2 minus?
Whoa, 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 whoa.
Is it 2 minus A?
Whoa, 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 whoa.
A divided by 2.
A divided by 2. Because how do you go from 4 to 2? Remember, this is a horizontal compression by half. So what we're going to do is multiply by half to A. 1/2 times A. B stays the same. So it'll be A over 2, comma, B. A is just like a number. Whatever you do to the number, you do to A. Why do A? Because I'm working with horizontal. What if I give you this? Y equals to F this will be 2/3 X. Okay. I look at this 2/3, and a lot of you think, hey, 2/3 is a small number. But in reality, 2/3 is a big number, because you got to use the reciprocal of 2/3. Hey, Brent. So guys and gals, write down what this does. Horizontal, I'm going to use H expansion, or you can use the word stretch. Expansion. Sorry? Because we got to use the reciprocal of 2/3. What's the reciprocal of 2/3? 3 over 2. If the number is greater than 1, it's a stretch. Okay?
3 over 2. Reciprocal.
It's 3 over 2. By 3 over 2.
So it matters only if the reciprocal is greater than 1 or between 0 and 1.
Yep. In reality, if a number is greater than 1, we know it's expansion. Because if I have a number multiplied more than 1, it gets bigger. Yeah, we're going to write it in a second. So this is expansion by 3, 2. Star. If a number is greater than 1, number is greater than 1. Okay. I'm going to use...
Shouldn't you say if reciprocal?
Okay. If a number is greater than 1, and I'm going to write a little bracket down. This is your final number. Your final number. Not 2 over 3, but your final number. Then, it is an expansion. It is an expansion. Okay. So we know this is expansion by 3 over 2. If my number, for example, was 8, 12, what would the new point be? Have fun with this one. So we know it only affects the x-axis. So 8 times 3 over 2.
18.
Oh, whoa, 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 whoa. 12. Because 8 times 3 over 2 is 24 over 12, which is 12. Guys and gals, what if I give you, merge them together now? Good luck. Y equals to 4f 1/3 x. You're going to tell me, number 1, English, exactly what happens. And then, once your English is correct, I'll let you do B. My point is -3, 4. I want to know what is the new coordinate going to be. And I'm going to pause it. First thing, I see there is an H expansion. H, there's a he by 3.
E by 3.
And there is,
She.
not a she, it's a vertical
A V.
VE expansion also by
Can you call that straight?
Can't you go
4.
stretch that?
Stretching called VS, you call it whatever you like. They all mean the same thing. So in other words, we know both of these are stretches. Now you got to be careful. Some of you will make mistakes right here. See, with the Y, what you see is what you get. I don't have to do any reciprocal. It's only when you work with the X. So when I do all this stuff, I would get, Bikram, what's your answer going to be? -9 and 16. If I want to be mean and say A, comma B. Oh, whoa, this is mean now. Okay. Randeep, what would you get if I use A comma B? Not 4A. 4B
How'd you get 16?
is correct.
How do we know it's 16?
And what about A?
What is that?
3A.
Negative 3 or 4? You said negative.
Nope, not nope, not negative. Because I'm using A's and B's.
Oh, yeah.
Because they're all, when you work with expansion and compression, it's always multiply. We're not adding. Okay. This is called expansion and compression. Now, here comes the fun part, theory. Oh. In theory, you gotta twist your brain around. Okay? Theory. In theory, remember, there's no f of x. This is how you know it's a theory question. F of x is gone. Bye, 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 bye. Okay. In theory, train your brain to think vertical. Okay. And the key is reverse your thinking. Reverse your thinking. This is the key for vertical. And what you're going to do is very similar to horizontal stuff. It's very similar. There's no difference. I'm going to give you a question. Good luck. Actually, I'm going to y equals to 3x plus 1. Y equals to 3x plus 1. First thing you should notice is there's no f of x. So right off the bat, this is a theory question. In theory, we're going to talk about stretches. You're going to replace y with ay. A. Okay, you're going to replace y with ay. If a, and this is where a lot of people are going to be confused, is greater than 1, this is a compression. Sorry? It's reverse. Compression by 1 over a. I'll explain it to you with numbers. It's easier to see with numbers. If a is between 0 and 1, it's an expansion by 1 over a. Same concept. I'm going to give you an example. I want you to look at this and say vertical expansion by 4. I want a vertical expansion by 4. Right off the bat, you're going to replace y with ay. So write in ay right now. Okay. I'm just going to do it very nice and simple.
Are we still using the original equation?
You're going to use the original equation. Nothing changes for x. I'm going to pause it. See, a lot of people will say, hey, so let's use this 4y equals to 3x plus 1. The problem with this is when you work with theory, everything is reversed. See, that 4 is not correct. You got to use the reciprocal of 4. So in reality, this should be 1 over 4. The reason why is when you get y by itself, this 1 over 4 actually becomes 4. So therefore, sometimes they may ask you to take it one step further by bringing the 1/4 over. So this becomes 12x plus 4. That's what theory is. What if I give you this? I want you to create an equation with a vertical compression by 2/5. A vertical compression by 2/5. Exact same equation. Y equals to 3x plus 1. What are you going to replace y with? That's what I want to know. Ay. Now find the value of a. Ay equals to 3x plus 1. What is the value of A when you work with theory? Think about this. Nisha, what do you have? 5 over 2 is correct. Because you got to use the reciprocal when you work with theory. Okay. So this is 5 over 2y equals to 3x plus 1. See, in theory, train your mind to think of reciprocals. Guys and gals, this is called theory for vertical. You can leave it like that, or sometimes they may take it to the next level, and they say y equals to 6x. They bring the 2 over, and then divide it by 5.
So it's the last two, the x and c starting always thinking with it.
Yep. The y is always switched. Horizontal theory. Horizontal theory is this. Stick to what you know. Just like what we for horizontal, nothing changes to what you know. Because when you work with horizontal, you're actually using theory to begin with, what you know. Okay. Only difference, replace.
Oh, your name wrong.
Yeah, I did. X with bx. Okay. I'm going to give you a question. Y equals to 3x plus 1. I want a horizontal expansion by 3. Horizontal expansion by 3. What are you going to replace x with?
bx.
Okay, you can replace it with bx. Everywhere you see an x, you got to replace it with bx. So I see an x here. Y equals to 3. See, I'm going to use bx plus 1. Guys, I'm going to pause it.
Does it become x plus 1?
Yeah.
Yeah, it is. See, when you work with horizontal, it's the same thing as x, f of x. If I want expansion, we know it has to be reciprocal. 3 times 1/3 x plus 1. So basically, this becomes x plus 1. Y equals 2. And that's your answer.
Give us another horizontal one.
How about when y? Did you get this part? 3 times 1/3? Hi.
Give us another horizontal.
I'm going to give you another one. Same concept. Actually, I'll give you this one. Y equals to x squared plus 2x minus 1. I want this to happen. Down. Oh, I should, eh? Yeah, I should give you a supernova question. I'm going to make this your supernova question for today. Good luck. Toot. This is an individual challenge. This is your supernova question. No, that's why I said horizontal. Stick to what you know. Here's your question. Your question is going to be this. Down 6. Horizontal compression by 2/3. Show me what you would get. So guys, down 6. So this is actually theory.
Y plus 3.
Y plus 6.
Or 6, sorry.
Okay. Sorry? Oh, because it's down. Now, here's where some of you made boo-boos. Horizontal compression. Some of you went 3 over 2 squared. But you're missing one thing. X. You have to have an x in here. Plus 2. 3 over 2. Again, look. Whoop. I'm using x. Okay. Minus 1. Oh, yeah, that's fine. Oh, sorry. Yeah, I got to give to you. I made one boo-boo. So, guys and gals, voila. That is how you do it. Is it that hard? No, not really. Your work for today. That's it. Know the difference between compression, expansion. No difference in theory. See, if I give you this, y equals to f of x. Create an equation. What would the equation look like if I give you this? This is going to be horizontal expansion by 3. Horizontal compression by 1/4. Down
Can you do
2.
horizontal?
Sorry?
Horizontal?
Oh, sorry. Well, this is vertical.
Compression and expansion.
What?
What's the difference between horizontal expansion and horizontal compression?
And when picture-wise? Are you talking about picture?
Like writing.
Writing?
Yeah, like what's the difference between it?
One, expansion. You expand it out. Compression, you shrink it.
Does you know what's in compressed by?
Vertical, horizontal compression by 1/4.
Like, at the end, you're gonna answer it? Is
Yep.
what you're trying to say?
Well, I'll show you with picture. Well, you need a diagram to show you, but that's for your homework. Guys, gals, what's your equation going to be that satisfies all these criteria? See, when y is equal to f of x, you can just go ahead and write it in straight. There's no tricks to it. This is not a theory question more. It's just a simple question now. You can rewrite this as y equals to, what number goes in front of f of x? 3. See?
F of 4x.
And this is f of 4x
Minus 2.
minus 2.
Also, you can just bring the minus
How do
2
you know
over.
the 3 goes in front of the... Why does the 3 go in front of the...
Because there's a vertical expansion. When you have vertical expansion, it goes in front of the f. Okay. Guys, gals, this is the sort of thing you be...
What if it was vertical compressions? Where would it go then?
Sorry, what?
What if it was vertical compressions?
Vertical compression?
Yeah.
If it's a vertical compression, then it'll be 1/3.
Okay.
Let's say, as this is the sort of thing you have to work with. You learn how to move left and right. You learn how to move things, stretch it up, down, and all that stuff. Your work. Page 7 and 8. Again, the work should be relatively simple. Should take you about half an hour to do.